This lesson is about logarithm equations. There are various ways to solve equations that contain logarithms. Let's review a definition. If both sides of an equation consist of a logarithm with the same base, then the arguments must be equal. The argument is the part in the parenthesis. So, for example, log base 10 of x equals log base 10 of 15. Since they're both a log base 10, then x must equal 15, and the answer is simply x equals 15. The next example, log base 2 of 4x minus 7 equals log base 2 of 33. Since they're both log base 2, then 4x minus 7 must be equal to 33, and you simply solve for x, and x equals 10. And our last example, log base 8 of 5x minus 9 equals log base 8 of x plus 3. Since the log base 8 is the same on both sides, then 5x minus 9 must be equal to x plus 3, and you simply solve for x. And there's your answer. The equation log base 4 of x equals log base 9 of 100 cannot be solved in this way, because the base on the left, a 4, is different from the base on the right, a 9. Here's another definition. If the variable expression is isolated within the argument of the logarithm, you might be able to solve for x by converting from a logarithm form to an exponential form. Remember, exponential form is b to the e equals a, base to the exponent equals answer. And logarithm form is log base b of a equals e. So let's see this example. Log base 3 of 4x minus 7 is equal to 4. We can just rewrite this logarithmic expression as an exponential expression because it really says 3 to the power of 4 is equal to 4x minus 7. And that's what I've written down. 3 to the power of 4 is equal to 4x minus 7. So you evaluate 3 to the power of 4 is 81, and then solve for x, and x equals 22. That's the answer to our original logarithm equation. Here's another definition. Given an exponential expression, you can rewrite it as a logarithmic expression, then use the change of base rule to solve for x. Remember, the change of base rule is log base e of f is equal to log base 10 of f divided by log base 10 of e. So here's an example. 2 to the what equals 100? Well, we can rewrite it as a logarithm, so log base 2 of 100 equals x. Our calculator doesn't have a base 2, so we rewrite it using the change of base rule, log base 10 of 100 divided by log base 10 of 2. You can calculate both of those and get a decimal approximation, and then divide, and x equals 6.643. That's how you solve the original question, 2 to what power is 100? Here are some practice problems to solve the following logarithm equations. Notice you have one of each. One equation where the log base is the same on both sides. Another equation where you have to rewrite it from an logarithmic expression into an exponential expression. And then an equation where you have an exponential expression and you have to rewrite it as a logarithmic expression. Go to the next screen to see the answers.